Example 7.3. A lamp is connected in series with the capacitor. Predict your observations for DC as well as for AC connections. What happens in each case if the capacitance of a capacitor is reduced? Okay, first we'll draw the circuit. Capacitor circuit, right? So, what is the opposition offered by capacitor for AC? That is called capacitive reactance. Xc equal to 1 by omega C, that is 1 by 2 pi Fc. So, Xc mainly depends upon frequency, right? Okay. Now, we'll go for the first part of the question. Capacitor is connected to direct current. This is capacitor. I'm connecting it to the battery. There is a direct current through the bulb. Capacitor, bulb, and direct current. Now, what happens to the bulb? Whether it will go or not. Capacitor blocks current after charging. Now, come to this formula. Very easily you can remember here. See, for direct current, what's the frequency? 0, right? So, substitute F as 0. 1 by 0 becomes infinity, right? 1 by 0 becomes infinity. What do you mean by infinity? Xc is equal to infinity. 1 by 0, that is infinity. Xc value is infinity. Means capacitor gives infinite opposition for the direct current. So, capacitor, we can say capacitor blocks direct current. No question of allowing the direct current to flow through this. In other words, you can say capacitor hates DC. So, no flow of current. Therefore, there is no chance for the bulb to glow. Whether you increase the capacitance or decrease the capacitance, always it is blocking. So, reducing C, no effect means bulb never glows when the capacitor is connected to direct current. Okay. Now, we'll go for the alternating current. Capacitor is connected to alternating current through the bulb. Now, what will happen? Come to the same formula. 1 by 2 pi Fc. Alternating current has some frequency. For example, in India, frequency is 50 Hertz. 1 by 50. There is some sort of opposition. But it is not infinite opposition. But for direct current, infinite opposition. For alternating current, there is some amount of opposition. So, whether bulb will glow or not, obviously bulb will glow. Capacitor allows current via reactance. Means even though it is having some amount of reactance, but current can glow, bulb will glow. Now, if you reduce C, what happens? If you are reducing C, 1 by C value reduces, Xc value increases. Xc value increases means opposition increases. So, opposition increases, flow of current decreases, the intensity of the bulb decreases. So, brightness decreases. So, we can finalize capacitor blocks direct current and allows alternating current. This point is very important. Capacitor hates DC but loves AC.